Welcome back. So we are continuing with the polynomials. So till the last video we discussed on remainder theorem. Okay. So in this video we will learn about factor theorem. This is again another theorem that is closely related to the remainder theorem. Okay. So if Px is a polynomial in one variable x with the degree n greater than or equal to 1 and a be any real number, then if p of a equal to 0, then x minus a is a factor of p of x. Conversely, if x minus a is a factor of p of x, then p of a is equal to 0. So this is the factor theorem. So factor theorem states that if px be any polynomial with degree n greater than or equal to 1 and a be any real number, then if p of a equal to 0, then x minus a is a factor of p of x. Alternatively, if x minus a is a factor of p of x, then p of a is equal to 0. Okay. So let us look at the proof of this theorem. So let us assume p of a is equal to 0. The first statement says if p of a is equal to 0 for a polynomial px of degree n greater than or equal to 1 and a be any real number. Okay. So by remainder theorem we know that p of a is the remainder. If p of x is divided by a linear polynomial of the form x minus a, then pa is the remainder. So here if p of a is equal to 0, it means when we divide p of x by x minus a, the remainder is equal to 0, which implies that x minus a is a factor of p of x. Alternatively, let us assume that x minus a is a factor of p of x. Then x minus a divides p of x completely, isn't it? So when we say x minus a is a factor of p of x, the remainder that we get upon dividing p of x by x minus a is equal to 0. We know by remainder theorem that p of a stands for the remainder when a polynomial p of x is divided by a linear polynomial of the form x minus a. Hence, since x minus a is a factor of p of x, p of a is equal to 0. Right? So this is factor theorem. See, we had seen certain algebraic expressions in our 8th standard. Right? These algebraic expressions are of the form x squared plus a plus b into x plus ab. Right? So we had seen exercises or sums in which you had asked to factorize an expression of the form x squared plus a plus b into x plus ab. So you will basically look for two numbers whose sum will be the coefficient of x and whose product will be the constant that is there in the algebraic expression. So I hope you will be able to recollect such sums that you have done in your 8th standard. Now, how do we factorize algebraic expressions of the form or polynomials of the form ax squared plus bx plus c? where a comma b comma c are real numbers. So we have to figure out a way to factorize such polynomials. Let us assume that ax squared plus bx plus c can be factored as a product of two linear polynomials. Let those polynomials be px plus q and rx plus s. Okay. So let us assume these are the two factors. So ax squared plus bx plus c is equal to px plus q into rx plus s, where p, q, r, s are all constants. Let us assume, these are the factors. Now when you multiply the right hand side, px plus q into rx plus s, okay, you will find out that the middle term x, right, the middle term x can be expressed as the sum of two numbers whose product is equal to a multiplied by c. I am repeating it. When you multiply px plus q into rx plus s, and when you simplify it, you will be able to find out that the middle term b can be expressed as the sum of two numbers, two real numbers, whose product is equal to a multiplied with c. Okay, right? So a is a coefficient of x squared, c is the constant. So you will be able to express this in this format. So if you are asked to factorize a polynomial of the form ax squared plus bx plus c, you know that the product of two numbers that would split the coefficient of x, which is b here. So b should be split into two. Okay, this is called splitting of the middle term. B is called the middle term. Okay, so we know that we will be able to split b into two numbers whose product is equal to a multiplied with c. So the modus operandi is, since the product of these two numbers, right, is equal to a into c, you will have to first list down, whenever you encounter such polynomials, you will have to first find out a multiplied with the c. You will get a number. Okay, you basically write down all the factors of that number, all the factors of a multiplied with c, ac. Okay, and now you find out of those factors which two factors when added would give you the middle term b. Okay, so those two factors are the factors that must be used to split the middle term b. Okay, so the moment you split the middle term into a sum of two numbers, right, then what will happen is you will be able to further simplify and find out the two factors. So let me explain you with an example. Let me take one example. See, 6x squared plus 17x plus 5. Okay, 6x squared plus 17x plus 5. So we know the product of, right, the coefficient of x square is 6 and the constant is 5. See, the product of these two numbers is equal to 30. Okay. The middle term is 17. So we will have to find out. So the middle term is plus 17. The product is plus 30. So how can we split the middle term in such a way that the product of those two numbers should be equal to 30? Right? So if you write down the factors of 30, you will know 15 and 2 are the two factors. When added will give you 17. And 15 multiplied by 2 is equal to 30. Okay. So you write 6x squared plus 17x plus 5 as 6x squared plus 15 plus 2 into x plus 5. Okay. So you will get 6x squared plus 2x plus 15x plus 5. Okay. So what is common between 6x squared plus 2x? 2x is common. So you take 2x out. So when you take 2x out, it becomes 2x into 3x plus 1. Okay. And in the next two terms, 15x plus 5, 5 is constant. So 5 is common, right? So you take 5 out. So it becomes 5 into 3x plus 1. So you have 2x into 3x plus 1 plus 5 into 3x plus 1. Now 3x plus 1 is common. So you further simplify. It becomes 3x plus 1 into 2x plus 5. So these are the two factors of 6x squared plus 17x plus 5. So let me repeat it. The example that we have taken is to factor 6x squared plus 17x plus 5. Now you take the coefficient of x squared 6 multiplied with the constant 5, you get 30. Out of the factors of 30, 15 and 2 are the two numbers which when added gives you 17. Okay. And 15 multiplied by 2 is equal to 30. Alright. So you split the middle term 17 as 2 plus 15 into x. So your whole polynomial will become 6x squared plus 2 plus 15 into x plus 5. Now further you can simplify 6x squared plus 2x plus 15x plus 5. Now between 6x squared and 2x, 2x is common. So take 2x as common. You take 2x out. It becomes 2x into 3x plus 1 plus, out between 15x and 5, 5 is common. Take 5 out. It becomes 5 into 3x plus 1. You further simplify because 3x plus 1 is again common. So you take 3x plus 1. It becomes 3x plus 1 into 2x plus 5. So you get the factors of 6x squared plus 17x plus 5. Okay. So this is basically a technique to factorize polynomials of the form ax squared plus bx plus c. In case if you have any doubts regarding this video, you please email us at askmentorguru@gmail.com. ask mentor mentor guru guru@gmail.com. See, these videos are meant to teach you the NCERT syllabus. Okay. So these videos are not meant to give you training to appear for competitive examinations such as JEE Main or NEET. Okay. So this is meant for you to do well in your classes, in your academics. So you have to do well in your 9th standard to gain confidence. So that is what these videos are meant for. Okay. So when you go through these videos, you need to have a copy of the book, either downloaded copy or a printed version, and you need to relate my videos with what is written in the book. Okay, then you will better understand about the portions, and in case further if you have any doubts, you should basically write to us. You should send an email to askmentorguru@gmail.com. Okay, so please wait for my next video where we will further talk about few more identities. All right, and these identities will be useful in solving problems. Please wait for the next video. Thank you.